Acids and bases vary in strength. Strong acids, like hydrochloric acid, tend to be more corrosive and dangerous than weak acids, like acetic acid. Strong bases tend to be more reactive and caustic than weak bases. Both acids and bases have a common property: electrical conductivity. The weak acid registers some conductivity, but the strong acid is a much better conductor of electricity. Conductivity is related to the number of ions per liter of solution.
Strong acids dissociate completely, producing more hydronium ions. Weak acids produce fewer hydronium ions in water. This explains why strong acids are better conductors of electricity than weak acids.
Strong bases are also strong electrolytes. Strong bases dissociate completely, forming many ions. Weak bases form few ions. The strength of the base is determined by the number of hydroxide ions formed in solution. The reaction rate is affected by the concentration of the acids or bases in solution. For example, a strong acid loses some of its corrosive power when diluted with more water. Molarity is one way of measuring a solution's concentration. Molarity is the number of moles of a solute in 1 liter of solution.
How can two acids of different strengths have the same number of hydrogen ions per liter? The strong acid is completely dissociated, but since it is very dilute, the number of ions per liter is very low. The weak acid only partially dissociates, but since the solution is highly concentrated, it has about the same number of hydrogen ions per liter. The strength of the acid or base and the concentration of the solution are two different characteristics that can occur in different combinations.
Compare these two solutions in terms of strength and concentration. You can tell the solution on the left is a weak base because there are few ions present. Only a small amount of solute is present, so the solution is dilute. The solution on the right contains a strong base because it is completely dissociated. The solution is concentrated because there is a relatively large amount of solute present.
The number of ions present depends on both the strength of the acid or base and the concentration of the solution. Even a weak acid or base can be harmful in high concentrations. Similarly, the destructive ability of strong acids and bases can be reduced by diluting the solution. Pure water may seem to be an inactive compound, but there's chemical activity going on in water all the time. You've seen that pure water cannot conduct enough electricity to light this bulb. But watch. This is an extremely sensitive device capable of measuring a very small current. The degree of conductivity is extremely small, but pure water does conduct electricity. There are ions in the water.
Sometimes one of the hydrogen atoms in a water molecule spontaneously breaks away and joins another water molecule, forming a hydroxide ion and a hydronium ion. Just as often as a water molecule ionizes, hydronium and hydroxide ions react to form two water molecules. The ionization of water molecules and the combination of ions to form water occur at the same rate, so they are in equilibrium and the concentration remains constant.
You've seen that acids dissociate in water producing hydronium ions. Bases in solution produce hydroxide ions. Since pure water contains both hydronium and hydroxide ions, is it acidic or basic? The concentrations of hydronium and hydroxide ions in pure water must be the same because one of each ion is formed when two water molecules react. Since there is never more of any one type of ion, pure water is neither acidic nor basic. It is neutral.
Hydronium and hydroxide ions are present in both acidic and basic solutions.
An acid is a solution in which hydronium ions outnumber hydroxide ions. The stronger the acid, the greater the relative number of hydronium ions. The reverse is true for bases.
Scientists found it cumbersome to express ion concentration using such long numbers, so a shortcut called the pH scale was developed. pH stands for power of hydrogen. When the mantissa of the concentration is 1, pH is equal to the negative of the exponent.
A pH of 7 indicates a neutral solution. Substances with a pH of less than 7 are acidic, and substances with a pH of greater than 7 are basic. Notice that the lower the pH, the greater the number of hydronium ions.